Professor Belfrost's computer science class is back!
Hi, welcome back to my computer tutorial. And today we will discuss about, yeah, we'll do some review on chapter of number system. I'm sure that you have got the concept, and this is just layer exercises for you to make sure that you have already understood the concept well. So there are some problems that I have prepared before. Let's see. Number one, so you are asked to convert the following binary numbers to the decimal. There are A, B, C, and D. All of these are binary. So if you want to convert binary to decimal, it's not very difficult. You just need to uh, multiply each of the digit with its own place value, okay, with its respective own place value. Place value is the weight of the bit itself. For example, for 10101 binary, so the leftmost one, it has the weight of 2 raised to the power of 4, and then the second one has a weight of 2 raised to the power of 2, and the rightmost one has a weight of 1, which is 2 raised to the power of 0. And you can do the same way to other B, C, D, and actually the decimal result is just the sum of the weight multiplied by its own digit. Okay, it's very simple. Number two, convert the following binary into the decimal numbers, but this time this is in fraction. So in fraction we do the reverse. Okay, if we in integer we multiply by 2, then um, with the place value of a fractional number, then we multiply by half. Okay, half raised to the power of um, yeah, its place. Okay, or 2 raised to the power of negative n. Okay, it's the same thing. And yeah, it's as before, we just need to multiply one by one and sum them together. Okay, number three, convert the following decimal number to the binary number. Okay, so here are all integers. So to do this, we just need to keep dividing it by 2 to convert it to the binary, and then we read it from the most significant to the less significant bit. Okay, which is the most significant bit is the leftmost one, and or the most bottom part, and the least significant bit is the topmost one. Okay, so here I show you 4 examples of how to do this for number 31, 57, 42, and 63. So I hope you to evaluate it by yourself carefully and understand how this works. Number 4, convert the following decimal number into the binary equivalence. And this time we have mix of integer and fraction part. So we must do them separately. For integer, we keep dividing by 2, as has been stated on the previous example, previous problem. And for fractional part, we keep multiplying by 2 until we get the value of 1.00 or 0.00. But if we cannot get that result, we cannot obtain that result, we can just express it in adequate place of binary value. Okay, but in this example I think that we can get to what we want, which is 1.00 here. Okay, so yeah, here are the 4 examples that I have prepared. I want you to investigate how to solve it by yourself. For number 5, we need to do the binary addition. There are also 4 examples here, 4 points. So actually binary example is binary addition is very simple. We just need to add in one by one. Please pay attention to the place value, okay? So I'll start from the rightmost one. So operation need to be done from the rightmost part. Okay, so you need to remember 0 plus 0 in binary is 0 with carry 0. 0 and 1 result in 1, and there's the sum in carry 0, and when we add 1 and 1 together, then the sum is 1 and the carry is 1 too. And by applying these rules that you can solve the respective A, B, C, and the A is the leftmost clip and the D is the rightmost clip, okay? So number 6, I think it's not difficult. Number 5, number 6, convert the following decimal numbers to the binary numbers 5 octal. So first we need to convert from the decimal to the octal, and then octal to the binary. So actually not very difficult, okay? Just take a longer step. So to convert from decimal to octal, for integer part, we need to keep dividing by 8. It's actually the same. This is the universal way you do where you are converting to binary, to octal, or to hexadecimal. You always do with the same way, okay? So I want you to disobey. I mean, disregard about the uh, row from table 20.1. Actually this because I take the picture from book, okay, but actually you don't need it. This is just what I've taught to you how to solve this, okay? So you keep repeating, dividing the integer part by 8, okay, and for the fraction part you just keep multiplying by 8 until you get the fractional part to be 0.00, okay? And yeah, that's how you do it, okay? And after you get it, then you just convert each of the number, okay, the octal representation into the binary representation. It's not difficult, right? Okay, because yeah, octal is very near to binary, okay? For example, you have octal 1, it means it is 001, okay? All octal representation in binary is in 3 digits, okay? For example, you have what say for example you have 8, uh yeah, I mean if you have 7, okay, I'm sorry actually let's see, yeah, all octal representation is in binary is 3 in 3 digits position, because the highest value can be represented by octal is only 7, 0 to 7. So 7 is 111 and 0 is 000. Okay, so that's how you do it actually. It's very easy actually. Just need to follow what I've taught you. Number 7, convert the following binary numbers to the decimal numbers 5 octal. It's the same as before, right? Okay, all we done by 5 octal. Actually, you can do it directly, but this just costs you a little more step. Okay, I just want you to exercise more on a problem like this. Okay, so from binary to decimal is very easy. Okay, from binary to octal, I mean, it's very easy because all of this has its own representation. For example, like 111 is 7, okay, and 0111, okay, 0111. You need to make in three, in a set of three, okay. So 011 and 100. That's how you do it. So 011 is 3, 100 is 4. So 7.34 in octal, then you just convert it into its respective um, decimal value by multiplying with 8 raised to the power of n, okay. N is the position value, okay. It's the weight of the digit, okay. It's very easy actually. You just exercise a very basic thing like this. Number 8, convert this, okay. You have actually it's not 5410, is actually 54 base 10, 200 base 10, 91 91 base 10, 281 80 238 base 10. I'm sorry, I mistyping. Okay, so it's all base 10. This is decimal number, and you're asked to convert it in hexadecimal equivalent. So yeah, to convert from hexadecimal to decimal, then you need from decimal to hexadecimal, you need to divide by the base, which is in this case, because it's hexadecimal, is 16. And then you just pick from the top, from the bottommost to the topmost, and write down the hexadecimal representation as shown in this slide. Okay, respectively it's A, B, C, and D. Okay, not very difficult, right? Next problem, convert this into its hexadecimal equivalent. Okay, to convert binary into its hexadecimal equivalent, actually it's easy. You just need to group in four set. I mean a set of four. Okay, you just need to group it into a set of four. What it means sets of four? Okay, it means that one group consists of four digits. Okay, for example, for the first one, 110 1 Okay, so you pick the four from the rightmost. Okay, you pick the four the four member from the rightmost. Okay, so start from 1 1 1 0, that's the first group, and then 1 0 1 1, that's the second group. Actually that's the same with B, C, and D. For example, for D, we'll take it 1 0 1 0, and that's the first group. The second group is 0 1 0 1, that's the second group. Okay, and then we convert the respective group into its equivalent in hexadecimal. That's very simple. Number 9, problem 9. Convert this into its octal equivalent. This is also easy. You just need to keep dividing by 8. And then you read from the bottommost to the topmost to create this representative in the octal equivalent, as shown at the slide. Okay, A, B, C, and D. Okay. The next problem is convert these two into its decimal equivalent. This is much easier, right? Okay, for the octal integer converting into the decimal equivalent, just need to keep to multiply each of the digit into with its respective weight. For example, 653, 6 is multiplied by 8 raised to the power of 2, because that is the weight on that position. 5 is multiplied by 8 raised to the power of 1, okay, and 3 is multiplied by 8 raised to the power of 0, because that's the weight of this position. That's the same too with hexadecimal, but hexadecimal the base is 16, not 8. So you just need to adjust the base, okay? So 16 cube, 16 square, 16 raised to the power of 1, 16 raised to the power of 0. And you'll get what you want, okay? Number 11, convert. Yeah, you have some thing to convert here. So you have to convert 2040 base 10 to octal and hexadecimal number. Easy. Decimal to octal, keep dividing by 8. What? Decimal to hexadecimal, keep dividing by 16. And then you get the result. The next problem, convert 300 base 10 or decimal into octal system by doing subtraction method. Okay, so here's another method that maybe I will introduce you when we are in our lesson. For subtraction method, you need to be sensitive. I mean, you need to pay attention to the place value. You need to consider the place value and its weight. Okay, so first we note that 300. What position may bring us the nearest but not exceeds the value of 300? Okay, we know that 8 raised to the power of 0 is 1, 8 raised to the power of 1 is 8, 8 raised to the power of 2 is 4, still far. Okay, 8 raised to the power of 3 is 112. That already exceeds what we want, right? So we must lower our concentration. So it is 8 raised to the power of 2. But 8 raised to the power of 2 times what will give us the value that is less than 300, but the multiplier must be an integer. We get this, that is 4. So we just subtract it from 4 times 8 raised to the power of 2, it brings us 44, and then we consider again. Okay, 64 is too high, so 8 times 1 will gives we it will gives us a integer value that is near to 44 but doesn't exceed that value, which is 40, right? So we need 5 as a multiplier, then we proceed it till we got 0. Okay, so the representation is 454 in octal. That's how we do in subtraction method. Next problem, convert this into octal equivalent. Yeah, we need to proceed it separately, integer, keep dividing by 8. For fractional part, keep multiplying by 8. That's how we do it. So the equivalent is shown in a slide. Next problem, we do addition and subtraction. So actually addition and subtraction is actually just two sides of coin. They can be done the same way. For subtraction, you just actually need to take the two's complement, okay, and just proceed with the regular addition. But actually this time I show you to do this by first converting it into the decimal, and then we add the result or subtract the result and convert it back to the binary. It can be done. This is legit as long as you have no sentence. I mean, you have no prohibition to do that in your exam. But I want you to try it in a way that I told you before. For addition, I think there is no problem with it because you have to addition the previous problems. I think it's number 3 or number 4 in the exercise. But for subtraction, just take the thing that we want to be the subtraction agent, make it into the what's called two's complement form, and then just do addition with the uh, number that we want to subtract. Okay, that's how we do it. Two's complement is just reverse all digit and then add 1. That is two's complement. It's easy. Number 15, you need to do multiplication, division, addition, multiplication, binary division. Oh, there are many. Okay, so actually for multiplication, this also show you how to do this by converting to decimal first, and I think this is a good way for you to start with. But actually you can do the same thing by utilizing your skill in direct binary multiplication. It's the same as the regular operation with decimal actually for multiplication. For division, also this here show you how to do it by converting to decimal first. But actually, you can also do it by using the binary way. Okay, maybe it takes is a little complex. Okay, to proceed with digits like 1 zeros, but actually it's worth trying. I want you to try for this with that way. Okay, number C, addition. This is the one that I've previously told you. You can just do it easily. For D, yeah, it's also the same as previous, but here this is how you do division. I've told you, right? By not proceeding it by converting first to decimal and convert it to back in binary. This is how you do it directly using the binary form. Okay, this is the E part. Another thing. Okay, easy. And yeah, that's done for our discussion. There's the review on number system. I think, yeah, I cannot explain much because this is actually mathematics. Okay, I want you to rewatch the video, pause on every slide, and evaluate the slide by yourself. Okay, that is the best way to learn because I don't want to explain all the lines one by one for you. Okay, now, yeah, here are some exercises for you to do by yourself. Okay, so please take a screenshot. There are 7 problems, easy, all very easy. And here is the key, the assignment answer key, the exercise answer key. Please check with this solution after you have done it by yourself. Okay, that's all for today. So here's a little quote for you. So Wayne W. Dyer once said, "Change the way you look at things, and the things you look at change." Yeah. So thanks for watching. Subscribe, give a like, comment, and share this to your friend. I'll be back on every Monday, so keep watching. And don't forget to visit our website on https://sciencewithxyz.unux.com, because by the time you watch this video, I must have posted some useful learning resources on that website, so you can, yeah, make that resource as your supplementary to learn this video. So keep watching and be thoughtful. Goodbye. See you in the next episode.